Alright, Chapter 13, Comparators. So far we've used amps on the normal linear mode with the file of the op-amp golden rules. No input current to either input, no voltage input, no voltage difference between the inputs. This week we look at capacitor specialties op amps, which are used positive feedback, no feedback. Competitors are sometimes use the op amp in its op amp saturated mode, where the output is pushed either to the far positive or the far negative. It can go. The user can change op amp with a linear device, a bistable device. This is one only two possible output values. The value output is based on a simple decision made by a chip. The positive voltage is greater than the negative voltage output. Positive rail not set up output with a negative rail. Such circuits called the comparator. This first step of the world digital circuits, where all output values are expressed in a series of yes or no answers to positive feedback. Rather, for the voltage positive of the reference voltage connect the input and negative voltage comparators supposed to determine the input and the input voltage negative less than the reference voltage. Output rails high. Input voltage negative is greater than the reference, then the output rail is low. However, the comparator looks at real input signals always faced by some small variation signal, make it harder to determine which input is greater. Even worse, electrical noise could drive the comparator through the many transitions you really wanted your signal to show. Only with the transition. Figure 13.1 shows the little noise added to the slowing, decreasing signal caused the multiple transition output. The top curve shows the comparator output. The bottom curve shows the voltage negative voltage input. Dash lines representing the voltage plus input. Figure 13 shows the noise signal on voltage. Negative voltage bottom generates multiple transition. Top goes from below the threshold voltage possible dash line. Voltage negative drop of the threshold dash of the output changes the shape when the noise makes the input voltage briefly. I'm going to go back above the dash curve. The output becomes bounce low with the back to high accordingly. Solution to the problem, with the positive setback simultaneously shift the reference voltage output changes the shape of the illustrated figure 13.2 with a shift large enough the output with less likely to bounce from the two output shape during the transition shift. It is called the hysteresis, depending on the design of the feedback network of the negative positive reference to output level. An example of how this might work, the op amp implementation shown figure 13, where the start of ignoring positive feedback node with the reference input is tied to 0.83 volts voltage divider formed by 10 kilohertz resistor. 50 kilohertz resistor. Now let's consider the effect of the feedback resistor. The output is high in place with a 100 kilo resistor. They include the 4.7 kilohertz for now, and the parallel 50 kilohertz resistor reference voltage goes up to 1.116 volts. Output of the 100 kilo resistor is parallel to the 10 kilo resistor, so the reference voltage goes down to 0.76 volts. Therefore, the circuit output will go to the high-low when the voltage negative increases beyond the 116 volt. The circuit output goes from low to high with the voltage increase of 0.7 amps when volts. Voltage is between 0.76 and 1.16 volt. Output stay with the current value either high or low. The memory of the past type of the feedback effect is called the hysteresis, often represented in a plot output voltage as a function of the input voltage. Hysteresis in this case can be given by a plot reference of the versus the input voltage. Comparator positive feedback network figure 3.14 to make two parts clear that they have been slightly offset vertically. This type of plot is called a hysteresis plot. There is an open box middle on the two paths that say that there's an input hysteresis to find the difference between two values in input where there is transition. The positive feedback in circuit is called a Schmitt trigger. Slightly better version can be with the two transistors beyond the scope of the chapter. B comparators, commercial comparators are special amps can come in a standard IC package. They are designed some of the purpose of the switching very quickly. Do not have the number of the other good amplifiers would exploiting negative feedback circuit and standard comparators. They will use these weak lab open collector outputs. Since comparators convert linear signal with a digital signal that routinely connect with the two dissimilar electrical systems with differential supply and reference voltage. Consequently, most standard comparators come designed to connect with any system you want to use. These output comparators actually collect input of the transistor switch open and closed states, where the actual output voltage node with a regular op amp, and then the output would maybe so form a push-pull stage. When your computator circuit is usually connected to the output voltage of the pull-up resistor shown in figure 13.5, when the comparator is high state, the switches will be open and no current will flow through the resistor. There will be no voltage drop again in the resistor, hence the output will be pulled to the positive supply. The comparator or low state switch is closed, current will flow to the resistor. There will be a voltage drop across the resistor, and the output will be pulled over the lower supply level of the ground, in this case 4.7 kilo ohms resistor, figure 330 of the pull-up resistor, figure 313.5, equivalent circuit of the open collector output pull-up resistor. Even though the real open collector states are open and closed, they still often call high and low assumptions for using a pull-up resistor. Comparator limitations. Comparators typically have a high gain, a high frequency, no phase compensation. Comparators are designed in the way of the negative rail and to the positive of the rail during transition. Data sheet the transition delay time when the time goes from one rail to another instead of the slew rate. The transition time of roughly 1 microsecond. Most serious limitations. Some compactors will not allow large voltage difference if the voltage positive, the voltage negative. The difference of differential input voltage should be looked up at the data sheet before designing a circuit. It should be specific comparator. Finally, another issue is the input of the circuit impedance change if the output state changes. Eddy triggers. Closely related class of triggers. If the rising edge of the trigger will be the pulse, fast, transition, low, high, back again, each of the time when the input voltage rises between particular threshold voltage. On the other hand, the input voltage goes back below the threshold, output stays low. The output is triggered, the threshold voltage is raised in a certain period of time to prevent multiple triggers. After this time is elapsed, the threshold is lowered back to the normal value. This is called rearming the trigger. Figure 313.6 of the output rising over the edge trigger sends over the pulse out the pulse of the top of the input. The bottom rises past the threshold dash line. The output stays low. When the output returns to be the low line of hysteresis, ensures that only one pulse is made with the transition, even if the presence of noise. 2. Oscillators. In many electronics applications, use a small functioning generator to synchronize various portions of circuits and insert time delays between different actions. This is called a clock signal. This should be used the concept of the trip of the store of the shopping with a printed circuit. Shopping for PCs that it will perform an individual operation single core proportional to the clock speed. Therefore, when we have 3.0 gigahertz PC, it will be 10 times faster than 2.7 gigahertz PC. Or a simple way to make it a clock signal with a positive feedback with a comparator to make a square wave generator. Example, the square wave generator shown in figure 13.7 is a circuit based on a comparative. The hysteresis of the comparator assuming the power at 0 voltage, positive 5 voltage. Divider is an example that divides transition level of voltage positive divided by 3 and second voltage plus divided by 3. The wrinkle here is that the output of the connected reference voltage of the RC circuit with the output with the switch state of the capacitor is charged with the voltage output when the charge of the capacitor gets higher than 2 volts plus divided by 3 hysteresis called the output with the transit state of the capacitor gets the discharge of the charge on the capacitor gets lower than positive volts over 3. Then the output changes state again and the process repeats forever. The resulting output is a square wave is shown in figure 13a. The square wave will have the period given by with roughly 2 linear lines of 2 RCs. So here we have a resistor going on output, and that is that. Show the voltage time. These kind of circuits are called relaxation oscillators, RC oscillators. Generally work as well with the frequencies for around 1 kilohertz, 1 megahertz. The design oscillator makes sure the resistor significantly large enough to pull up resistor output will be asymmetric. Can you figure out why a precision application simply RC oscillators would be replaced by vibrating crystals? Vibrating crystals available to precision oscillators wide range for the frequency. Just as designed for crystals, the comparators are available in data sheets, and then it goes into the design exercises. And we have now finished the introduction to analog circuits in the free book CenturyNet electronic books download Introduction to Analog Circuits, authors Eugene Lee Mikhoff.